Welcome. This is Odumat. Today I want us to look at calculus, and then under calculus we are looking at different rules of differentiation. Let's ask ourselves, what is differentiation? So differentiation is simply finding the derivative, or finding the derived function, or finding the differential coefficients, or find the gradient function of a function. Okay, so now let's look at the rules of differentiation. So the first rule we are looking at is differentiation of a constant. So let's y equals the constant c. Now how do we differentiate this constant c? Differentiating is just finding the derivative dy dx of this constant. So we can say this is the Leibniz notation. Leibniz notation. Okay, that is sometimes it is called the French, called the Leibniz notation. Y is equal to c can also be written as y is equal to cx, and x is having to the power 0. So any number to the power 0 is 1. 1 times c is still c. Okay, so now let's see how we can differentiate this, or when the constant is differentiated, what is the result? Okay, now the rule says that we subtract 1 from this power. Before then, this power should multiply whatever here we have here. So that is dy dx becomes 0 times c, which is 0 times c, then times the x, and x is having a power 0 minus 1. Okay, so we are going to have 0 times c, and c is having a power negative 1. Okay, so now when you multiply everything by 0, we are going to get 0. So the answer for this, when you differentiate the constant, you are going to get 0. Okay, so now let's look at the next rule. Okay, so let's look at differentiation of ax, and this time a is the constant. So let's y equals ax. Okay, so like we did earlier, there's this x is having a power 1. Okay, so we need to subtract 1 from this. Now dy dx becomes, so 1 times a is a. Then this x, this one here should be, there should be a minus 1 from this one. So 1 minus 1, and that is going to be a x to the power 0. And we know that any number to the power 0 is 1. So the answer becomes a. So when you differentiate ax, you need to get a. For example, when you differentiate, let's say y is equal to 2x. Okay, so the same procedure, this is having a power 1. So when you subtract 1 from this power here, you are going to get y to be equal to 2. So that is dy. So for this one, dy dx becomes 2. That is, this is going to be 0. And 0, x to the power 0 is 1. So we'll be left with 2. Okay, now let's look at the next rule. So the next rule we are going to talk about is differentiation of x to the power n. So if y is equal to x to the power n, how do we differentiate this? So like we said, we subtract 1 from this n. Before then, n should multiply this x. Then we take 1 from here. So that is going to be dy dx is equal to, this n times x is nx. Then we take 1 from this n, that is n to the power n minus 1. X to the power n minus 1. Okay, so that is the answer. Now example, let's say we have y equals x to the power 3. So this dy dx becomes, this 3 will multiply this x, so that is 3x. Then we take 1 from this, so that is going to be 3 minus 1, and which is going to be 3x squared. Okay, so when you differentiate x to the power cube, or x to the power 3, we are going to get 3x squared. Okay, let's take another, or let's look at the next rule. So now let's look at differentiation of ax to the power n. So if y is equal to ax to the power n, so we need to subtract, we need to multiply n to a and then x. So we are going to get nax. Then we subtract 1 from this n. So dy dx becomes nax, that is n times ax. Then we take 1 from the power n minus 1. Please, we need to be attentive to this one, or pay more, or be mindful of. We need to be mindful of this one here. So if there is a here or there is no a here, this should multiply whatever we have here. Okay, let's look at an example. So let's say we have y equals 3x squared. Okay, so dy dx becomes, this 2 should multiply this 3, so that is going to give us 6. Then we take 1 from the 2, so that is going to be 6x to the power 1, but we don't write the 1, so the answer is 6x. Okay, let's look at another example. Okay, so now let's look at these examples. Find dy dx if a, y is equal to 2 over x cubed, b, y is equal to 1 over square root of x, then c, y is equal to 3 root x. Please, this is not cube root, this is 3 times root x, 3 times square root of x. Then d, y is equal to 5 over cube root of x to the power 4. Okay, so let's take them one after the other. Now the first one, y equals 2 over x cubed. So we can rewrite this as y equals 2 to the power, 2x to the power negative 3, because the 3 here, the x here is the denominator. So when you write it in this form, then the power should be a negative. Okay, like the indices we learned some time ago. Okay, so here we need to find dy dx. So our dy dx becomes negative 3 times 2 is negative 6. Then you subtract 1 from here. So negative 6 to the power, negative 3 minus 1 becomes negative 4. So we can rewrite this as our dy dx becomes negative 6 over x to the power 4. Now let's look at the second one, b. Y is equal to 1 over square root of x. So we can rewrite this as y equals 1 over x to the power 1 over 2. That's the square root. So the 2 here is coming from the square, and then the 1 is also from this power here. Okay. Now, and this can also be written, or we can rewrite this as x, that is 1 times x is x, so x to the power negative 1 over 2. So our dy dx, which is going to be negative 1 over 2 times x, becomes negative 1 over 2x. Then we take 1 from this side. So half minus 1. Half minus 1, or negative half minus 1. Negative half minus 1 is just like adding the two negatives. So that is going to be negative 3 over 2. So to the power negative 3 over 2. Okay, and the final answer becomes negative 1 over 2. Then we can say that this is being multiplied by 1 over square root of x to the power 3. Okay, so this finally becomes negative 1 over 2 roots x to the power 3. So this is a little bit tricky, but it's nothing. So we had this negative 3 over 2 as being the power. So like I said earlier, this 1 here is from this power, the unwritten, the power that we are not writing, the power here. Then the 2, the denominator 2 is the square roots, is the square roots. Okay, so when you come here, we have negative 1 over 2, this one, let's it be aside, then negative 3 over 2. So this becomes the square roots here, then the 3, negative 3 here becomes the positive 3. And I've changed this one to the fraction form. That is why you are not seeing the negative 3 here again. Okay, so when you have, let's say, square root of a is the same as a to the power negative, a to the power half. So when you have 1 over square root of a is the same as a to the power negative half. Okay, because the square root of a is the denominator, so we can change this one to that. So this becomes the final answer to the question B. Now let's look at the third one. Okay, so the C, that is y equals 3 root x. So y equals 3 times square root of x. Okay, now let's rewrite this. So y becomes 3 x to the power 1 over 2. Now our dy, the x becomes half times 3 over 2, just like half times 3, or 1 over 2 times 3, which is going to be 3 over 2. So that is 3 over 2x. Then we take 1 from here. That is going to be half minus 1 is negative half. So our dy x becomes 3 over 2. Let me write the final answer. So that is going to be 3 over 2 roots x. 3 over 2 roots x. Okay, so let's look at the final question. So let's learn how to rewrite something of this nature. So this is going to be y equals 5 over, now this is x to the power 4 over 3. So 4 over 3. Okay. And we can rewrite this again to be y equals 5 x to the power negative 4 over 3. Okay. So then our dy dx becomes negative 4 over 3 times 5. So negative 4 over 3 times 5. Then x to the power, now you subtract 1 from this. So that is negative 4 over 3 minus 1. So we can do this here and then come back. So negative 4 over 3 minus 1. The LCM is 3. So 3 into itself 1 times negative 4 is negative 4. Minus, here there is over 1 here. So 1 into 3 is 3. 3 times this becomes 3. So that is going to be negative 7 over 3. This and this becomes negative 7. So negative 7 over 3. So we have this to be negative 4 over 3. Negative 4 times 5 is 20. So 20, negative 20 over 3. Then x to the power negative 7 over 3. X to the power negative 7 over 3. In subtracting this, we can look at it this way, this simple way. So negative 4 over 3 minus 1. Okay, I can rewrite this one to be 3 over 3. So that's going to be 3 over 3. Because 3 over 3 is 1. Okay, so now the answer. Since we have the same denominator, we need to just add the numerators. So negative 4 minus 3 is negative 7. So negative 7 over 3. That is what we have here. And we can change this answer to be negative 20 over 3, then square roots, cube roots of. So we need to be careful writing this, because the 3 here will make it so 3, then cube roots of x to the power 7. Okay. We need to be careful writing this. This is 3 cube roots of x to the power 7. Okay, very interesting. So when you get to this side, you can also, maybe before working, you can try and then pause and get your answer, and then after you compare. Okay, please don't forget to subscribe. The name has always been Odum Maths. Thanks for watching. You can check on this at TikTok and then at YouTube. Maybe one of these days, some few will be on Facebook. The name is Manuel Odum on Facebook, TikTok, odum.maths, and then on YouTube, Odum Maths. See you in the next lesson. Bye.